All right, we should be recording now. I guess I'll get started. Okay, hopefully you should all be able to see my screen right now. I'm on the PowerPoint that I sent in the chat. If you weren't here a couple of minutes ago, I mentioned that I put this PowerPoint in the chat. I'll link to this PowerPoint in the chat, and this PowerPoint is going to have all the things you'll need to know if you want to set up the environment that I'm about to show you yourself. So I go through it step by step. I show you every step of the process and tell you what to do. I know it's a lot of work, so if it's not something you're interested in, once again, I put a form at the very end of the presentation that I'm going to have you fill out at the end of the seminar, or if you're not staying till the end, please fill that out on your own time, or you could do it right now. And that'll basically ask you for a username and password in case you want me to give you access to a virtual environment that I will set up for you, and I'll let you know how to access that. So yeah, you don't have to go through this whole grueling process. But basically, I'll be starting this presentation on slide, where was I? 67. So if you wanna share, I can send the link again. Oh, I forget you probably don't see old chats, do you? There, and paste, and now you should have the link again. Let me know if you have trouble opening that, but you shouldn't. Okay, so let's talk about the basic concepts that are involved in cybersecurity. And to do that, no problem. First, we have to talk about network communication. So how does network communication work? Well, essentially, there's two computers or two machines. Can be any sort of device. It can be a computer, a server, or a phone. And one always acts as the client, and the other always acts as the server. Now, what does that mean? That means that the server is going to say, hey, you can connect to me. And then the client is going to reach out to the server and attempt to connect to the server. So that's only for setting up the connection. The server always goes into what's called a listening state. So that means it's saying, I'm listening for other machines that want to connect to me. And the client says, okay, I'm going to go ahead and connect to you. Now, how do we differentiate between different types of connections? Because as you probably know, on a computer, there are a number of services running, and they each have to be running concurrently and all connected to the internet. So how do we do that? Well, we do that by dividing it up into what's called ports. Now, ports is a unique number that you use to identify the specific communication that you're currently having. So for example, let's take an example. If I'm connecting to a website, right, the port used for website traffic is port 80. That's the number of the port. So whenever I'm connecting to a website, I'm going to go to the server and I'm going to say, hey, on port 80, I would like you to send me back the website that I want to look at. Now, of course, there are other ports on the server. That's why I put these ... There's way more than 3. I just couldn't fit them all. And each of those ports are running different services are running on those ports, meaning different connections are being made on different ports all at the same time. So that's how that's handled. Now, next we come to the idea of IP or Internet Protocol addresses. There are two types of IPs, public IPs and private IPs. So a public IP, it means that your computer or your machine is visible to the internet. So for example, here if we look at this server, it has a public IP, which means it's visible to anyone on the internet. This cloud represents the internet, can also be called the cloud. Now a private IP, on the other hand, a private IP is it's not visible on the internet, but it's visible to other computers that connect to the same network. Now, what is a network? A network is a way of connecting multiple computers. That's essentially what a network is. And it is oftentimes done through a router. Now, what a router does is it allows all these little computers that are connected to it to communicate between each other without necessarily having access to the internet. Now, from there, if you want to have access to the internet, your traffic is the information that you send out into the internet or retrieve from the internet. It goes through the router, meaning you send it to the router, and then the router then sends it to the internet. Yes, that's exactly what I'm talking about, actually. I'm talking about a local area network is behind the router. So it's not visible to the actual internet, whereas a worldwide area network, or WAN, means direct connection to the internet. So yes, so on a local area network, thanks for that terminology, that means all these computers that would be connected to this router, they can communicate with each other, but they're not necessarily communicating with the internet. Whereas with a worldwide area network, that means these computers are communicating through the router to the internet. That's accessing the worldwide area network. So one other thing I should mention in terms of public and private IPs is that every single computer that's connected to a router does not have, as I was sort of mentioning, direct access to the internet. It has to go through the router. That means no computer has a public IP address. Computers only have private IP addresses. Now, routers have both public IPs and private IPs so that they can communicate both with the computer and with the internet. The public IP allows it to communicate with the internet. The private IP allows it to connect with the computer. Now, a server, on the other hand, is kind of a special type of computer that's set up so that it has direct access to the internet. It does not have to go through a router. So it generally only has a public IP. Now, what's the purpose of these IPs? Well, IPs are used to differentiate between different computers. So if I wanted to connect to a server, I'd have to know, one, its public IP address so I could connect to it, and two, I'd have to know the port I want to connect on so that I can differentiate between all the different services that are running on that server. I don't know if that makes sense, but hopefully it does. Now, going on to the next slide, I'll talk about some of the most common protocols. Now, what is a protocol? A protocol is a preset way of communicating with another computer, or in other words, a set of instructions that you send to the other computer so that it understands what you want from it. Now, of course, if two computers are communicating between each other and there's no set protocol, then they'll have no idea how to communicate between each other. But if they have a set protocol, meaning they know one computer knows that first they have to send a connect request to the other one, and then the other one has to respond to them, and they're both aware of this protocol, then they can communicate with each other successfully. So there are two main types of protocols. The first one is transmission control protocol, and the second one is user datagram protocol. So transmission control protocol, also known as TCP, is more geared towards accuracy, but at the expense of being slower in data transfer. So what that means is that the information that I am sending to other computers is almost certainly going to be accurate in what I want it to send, but it might not necessarily send as quickly. The reason for that being is it adds extra data or extra bits as checks to make sure that the data sent is correct or accurate. Now, whereas the user datagram protocol, it might be a little less accurate, so you might lose some data here and there, but it's a lot faster than TCP because it doesn't have all those extra bits of data that it has to check to make sure that the data it's supposed to send is accurate. Now, some of the most, I just wrote a couple of the most common TCP protocols that you may have heard of. First one is HTTP, that's used for websites. HTTPS is also used for websites, but it has an additional layer of encryption on it. That basically means that you can send the data encrypted so that nobody who's in the middle can look at what you're sending back and forth. SSH is secure shell. That's what you use to connect to another computer and just see the terminal, as opposed to seeing a nice desktop. There's also a RDP, remote desktop protocol, that allows you to see an entire desktop. I'm sorry if I'm going a little slow. I'm trying to make this geared toward everyone, whether you're in technology or not. So if you know all this stuff and you're like, ah, this is boring, then I apologize. Now, what are the ways in which we can attack a target computer or break into somebody's computer? Well, there are two ways of doing it. somehow we have to establish a connection with that computer, right? So since there are two ends to it, there's the server end and the client end, and the client always connects to the server who's listening for the client. One way we can do it is we can send some sort of malicious code to our target, and they're going to act as the server. So they're going to listen for incoming connections, and then all we have to do is connect to them, and then we can remotely control their computer from there. So that's one way of doing it. Now, the second way, that's called a bind shell. The second way of doing it is called a reverse shell, and that's where we do pretty much the opposite. So first, we actually open up our own computer, listening for incoming connections, and then we give the target a piece of malicious code that connects back to our computer, and from there we can communicate between the target and us. Now, there are some advantages actually to the reverse shell over the bind shell, and that is that back in the early days when people were breaking into computers, what computer manufacturers realized is that anytime they open up the computer for listening, that is a potential security vulnerability because somebody could connect to their computer. So, of course, you have to be able to connect to other computers, right? Because you have to be able to access the internet. You have to be able to, I don't know, do file sharing, but you don't necessarily have to open up your own computer for that. So what they decided to do is they put a firewall that blocks this computer from being accessed by other computers. However, it does not necessarily block outgoing connections from the computer. So that's why the reverse shell comes in handy often, because even if they have a firewall that's blocking incoming connections, incoming means coming to the target can still make outgoing connections to the attacker, and they can connect that way. Now, there are 4 stages to pen testing. Pen testing is the real term for hacking. And I should say it's a subsection. Hacking is a very broad term, whereas pen testing is like what you actually would think of when you think of hacking. The first stage is information gathering, where you're looking at the network that you're going to try to break into. You're looking what computers are on it. You're looking what services are running on those computers. You're learning about those services, maybe even by doing Google searches. And you're learning about the vulnerabilities that might be in those services. The next thing is vulnerability analysis. Vulnerability analysis is very similar to information gathering. It's kind of considered its own separate category because usually information gathering is stuff that you do on your own. And by you do on your own, I mean you actually go out there and you scan the computer and you analyze the results yourself. Whereas vulnerability analysis is using pre-built tools like OpenVAS or Nessus or Nexpose that will undergo a similar process and do a lot of information gathering for you and alert you if there are any vulnerabilities to be found. Now, exploitation is when you actually break into the other computer. Now, believe it or not, this is probably the shortest stage of all of them because the breaking into the other computer is not the difficult part. The difficult part is figuring out how to do it. So 75% of your time is probably going to be spent just in information gathering. And then when you finally found what you think is a way in, you get to try it out. Post-exploitation means after you've already broken into the machine that you wanted to break into, where can you go from there? So that includes things like finding passwords that are on that computer that will allow you to break into other computers, taking screenshots, keystrokes, stealing credentials, that sort of thing. Now let's take a slightly deeper look at exploitation. Exploitation, once again, is the process of breaking into another computer. Now, there are some terms that you should be familiar with if you're going into exploitation. One is an exploit. An exploit is the means by which you break into another computer. So usually you say exploit when you're referring to the script or the code that you gave to the remote computer that allowed you to break into it. Because the remote computer, you always need to pass some code to the remote computer, otherwise it won't do anything. And that code is either going to create a bind shell or a reverse shell, as we talked about earlier. Payload is the malicious code itself that is being passed on to the other computer. So sometimes when you pass code onto the computer you want to break into, you'll pass in the payload, which is the malicious code itself, along with other padding or things that make it work with the specific service you're targeting that isn't necessarily allowing you to break into it, but is kind of messing with the process in such a way so that when you give it the payload, you'll be able to break into it. So payload is a subsection of the exploit. Now, shellcode is the lowest level machine code you can possibly get. So this depends on computer architecture, meaning the operating system that it runs. And ideally, whenever you break into a computer, you want to break into it using shellcode, or you want to pass it shellcode and run shellcode on that target computer, because shellcode cannot be misinterpreted. Different computers come with different ways of interpreting code. Some can interpret C code, some can interpret Python code, but every computer, as long as you have the correct architecture, can interpret shellcode. Now, two more terms we should talk about, kind of going along with these. So the name of the actual file that you pass to the remote computer that does something harmful to it is called malware. So malware is anything that does something negative or something that the person using the computer doesn't want it to do. Now, a backdoor is a specific kind of malware that allows you full access to the other computer. So malware is a broader category that can encompass things such as maybe deleting certain files on the other computer, but you never actually get access to it. Whereas a backdoor is you specifically are getting access to the other computer. And that's kind of what we're going to be talking about most. So now would be a good time, if you haven't already, to fill out the cybersecurity interest form. That basically lets me know that you're interested. I will send you a bunch of cybersecurity resources so you can get started if you want to get a head start. And maybe I'll set up an environment for you if that's what you want, or you can set up one yourself like I did here. Now, we need three things for our penetration testing environment. And I'm using VirtualBox, which is a virtualization technology that basically lets you run operating systems on top of your current operating system. So I'm on a Windows computer. However, I have three other operating systems running on top of it. The first one is Kali Linux. Kali Linux is the standard Linux distribution that is used for penetration testing. So it has all the built-in tools that will be required in order to break into other computers, basically. There are some other ones. I know another popular one is Parrot OS, so maybe look into that as well if you are really curious. But Kali is mostly the industry standard for that. Metasploitable is a purposely vulnerable Linux machine that I'm going to use to demonstrate the most basic of attacks, because I don't want to get too fancy today. So it's been purposely made so that you can attempt to break into it. Then this is a standard Windows 10 computer that I literally just downloaded off the internet. So it comes with all the latest Windows 10 features from 2008. And so the idea of having both Metasploitable and Windows is that the Metasploitable is the vulnerable machine that you break into very easily, and you can practice a lot of different ways of breaking in, whereas the Windows machine is the difficult one that's harder to break into, so you usually would do things like social engineering attacks, where you attempt to fool the person who's using the computer rather than finding vulnerable processes on the computer. I'm just going to give you a couple, everything's in the PowerPoint for how to set this up. I'm going to give you a couple quick tips that I ran into when I was setting it up a second time that I didn't notice when I created the PowerPoint. So a quick thing, if you're setting up Metasploitable and it doesn't run the first time and gives you a CPU error, you're going to want to go to System Processor and check this box that says Enable PAE/NX. And that should solve that for you. The way I have, just a quick note, the way I have the network set up, I do not want this to have access to the internet because this is a very vulnerable machine. These two can have access to the internet because they're pretty much secure. So with this one, I have it connected to NAT, which allows it to use the internet off of my host machine. My host machine means the Windows computer that it is running on top of. And it has an additional adapter connected to a NAT network that I created for these three machines. They're all connected together on one NAT network so they can communicate with each other. Yes, thank you for the link in the chat. That is terrific. It's also in the PowerPoint. If you look at the first page, I put all the links you will need. If you go to, or second page, you go to downloads. Here you have VirtualBox. Here you have Kali Linux. Here you have Metasploitable, and here you have Windows 10. So hopefully that should be helpful. Well, let's get started. I'm going to kind of start going quickly now. I'm just going to show you a bunch of different attacks. So I'm not going to explain them super well. I'm going to explain to you the general theory of what I'm doing. So if I go a little fast, I apologize. If I can enter my password correctly. All right. Now, the first thing I do when I have a machine up is I'm going to want to change my password so that it's something not the default password, because default passwords are bad, especially if we're exposing this to the internet. So I type PASSWD. That allows me to change my password. I'm not actually going to do that because I already did that. So forget that. But ideally, you want to do that the first time you log in. Now, the first thing I'll be showing you, we're getting into the first step of the four-step penetration testing process. That's information gathering, vulnerability analysis, exploitation, post-exploitation. So first, we're doing the information gathering. We have to see what other computers are on the network. So I'm going to use Nmap, which is a tool for doing network scans, and I'm going to do -sn, which allows me to do a ping scan. With any of these commands, if you ever forget what anything does, you can try -h or --help, and you'll get a really nice help screen that gives you all the options. These are called flags that you can add on to the end of the command that you can use to modify it to do what you want to do. So Nmap, I'm going to do a ping scan of my network, and my network here that I am targeting is 10.0.2.0/24. The /24 tells it to do the whole network from 0 through 255. If you're curious about that, there are a lot of good videos on it, so feel free to look those up. If I do that, I apologize. Takes a little bit, but it tells me all the machines that are currently up and on this network. Some are undiscoverable, and you actually have to use a I think it's PN scan, which is a little different from a ping scan. But for our purposes, all of these showed up. This is the computer I'm currently using. The way I know that is because I can type IP-addr or IP-addr. I can probably type IPA as well. Yeah, that works too. And then I have my own IP address here, so you can see that that's the same one as what we had here. So that's me. My Metasploitable machine is, I think this one. That's the vulnerable Linux machine. This is going to be my Windows machine. If I ever want to, speaking of Nmap, if I ever want to check the operating system of the machine that I'm targeting, let's say I wanted to target the Metasploitable machine. This doesn't always work because they just look at the services that are running on it and they make an estimated guess on what machine it is, but it usually does a pretty good job. Also, I forgot to give sudo privileges, so let's do that. Or root privileges, I should say. Yeah, so it recognized it as Linux 2.6.x, which is true. Metasploitable is a Linux 2.6 kernel. Really quick thing, I'm going to go sudo su. This is not good programming practice, but I don't want to have to keep typing in sudo. So I'm just going to do that so I don't have to keep typing it in all the time. The nice thing about Nmap, if you're familiar with grep, is anything you do, you can output it in a greppable format. What that means is you can output it to a file and then use grep on it. So I'll give you an example, .o.2. I'll do that ping scan again, /24, and then I'll output greppable, and I'll call it greppable if I can spell. And then once that's done, I'll be able to take the file, and grep for specific keywords, and that gives me a really nice view of just which ones are up rather than all this nonsense, messy nonsense. I don't know if it's that useful here, but it can be useful in other places. And then of course I can do things like make it just isolate these IP addresses, so I only know the machines I'm going for, and there I have a list of the machines I'm going for. And of course I could output that to a file or do things like that. So the next thing is, once you actually decided a machine that you want to target, so we're going to be targeting Metasploitable first, which we know is 10.0.2.5. We're going to conduct a basic scan. Now what this does is it scans the services running on the ports, and it also, I believe this scans the services running on the ports, and this uses the default Nmap scripts on all those services. So Nmap has some built-in scripts that give you information about certain services. And we're just going to go with the top 25 ports just to keep this kind of quick. I say kind of quick, but it's actually going to take forever. No, hopefully not. Anyway, while we're waiting for that, I can kind of tell you what the output of that will look like. At the top, you'll see the first thing I'm going to go after is VSF TPD, because we'll notice that, there we go, much better. So you'll notice that here we have the ports that it scanned and which ones are open. And it tells you what service is running on them if it knows the service. Now this is VSF TPD version 2.3.4. So now from here, we basically just go one by one and see which of these services are vulnerable. So I'm going to start with this one first. I actually know it's vulnerable because I did this earlier today. Now there are a couple ways to search for vulnerabilities. There's ExploitDB is the kind of the official hacking database where people who are really into exploitation and specifically look at finding vulnerabilities in services, that's where they post all the results that they find of possible vulnerabilities. There's a really quick way. I normally like to actually Google search ExploitDB and then that service. I literally type in this and ExploitDB. But just for the sake of showing it, there's also a command in Kali Linux that searches that for you, but it just searches like the names of it and some details. The names of the different exploits that you have available and some basic details. So we'll notice that here we got extremely lucky. We have a backdoor command execution. So that means we can potentially get full access of this machine. Then from here, this is the file where that the code for doing that is located. So the way the penetration testing process works is once you search for the service you need, you will usually look at a piece of code that somebody created that allows you to break into it. And you'll have to make sure that code works, and you'll have to modify that code if it doesn't work. There are going to be a lot of people, be careful, there are going to be a lot of people who post stuff that like messes with your own computer, just totally doesn't work, just because people are devious like that. But if you take a look at the code and you know kind of what it does, and sometimes you'll have to make some major modifications if you're doing it on a slightly different, if you're targeting a slightly different system than the one they tested it on, then you're going to end up using that code to break into the machine. In this case, we're going to see where this is located. I'm just going to use the locate command because I don't remember where all these are located off the top of my head. 17491.rb, and it's located here. So I'm just going to copy it over. I'm going to copy it over to the current directory that I'm working in so that I can take a better look at it. All right, it's there. And now I'm going to just take a look at it. I don't think I have to sudo for this. 7, there we go. And now that I'm looking at it, I don't really have to go through all this code because I can see right away that it's actually a Metasploit module, and that's pretty typical of Ruby code that they're integrated with Metasploit. Metasploit is one of the most popular exploitation frameworks that has, it's a community maintained framework where a lot of vulnerabilities are already kind of put on there, and you can really easily execute them instead of having to look at a bunch of code. You have some options that you go through, you choose the options you want, and you perform the exploit. That's exactly what I'm going to do right now. So I'm going to go on Metasploit, which I already have open because it takes a little while to open. And I noticed this was called VSF TPD 2.3.4. So I'm going to go search VSF TPD 2.3.4, see what I find. Oh, look at that. We have a module for it right there. Metasploit is organized into what's called modules. Modules are basically different code files that are attached to it that you can make use of and customize and then use. Usually you have a separate module for each attack you're trying to do or each scan you're trying to do. So we're going to use this module by going use and pasting that. Hopefully I copied it. Yes, I did. So now we're using that one. And then we'll see what options we have. Looks like we have to set our host. Our host means remote host. So that's the computer we're trying to break into. And the remote port is 21. We can actually check, make sure that was the port. So you'll notice that VSF TPD was running on port 21. So that is correct. It's by default going to use this payload. Remember, I talked about payload is the actual code that allows you, that causes the connection between your computer and the computer you're attacking. So in this case, this looks like a basic command line because it starts with CMD. So we're not going to have too many fancy options. Like Metasploit comes with what's called the interpreter, which gives you a lot of really nice additional commands that you can do, as well as the basic commands that you can do on any system. But it looks like we're just going to have basic commands here, which is fine because as long as you have basic commands, you have access to the computer. Also, I should have mentioned this earlier. Ideally, what you're aiming for is root privileges or administrator privileges. Administrator is the Windows version of root, kind of. And that basically means you have all the possible privileges you can have on that computer that you have attacked. And you can basically do anything you want with it. Otherwise, I'm sure you're all familiar with user privileges versus administrator privileges. So we're also, just for the sake of showing this, I'm going to set the payload to that just to make sure it is that. You do that by saying set payload. We're also going to set our remote host, which is the one we're trying to attack, to the IP of the machine we're attacking, which is 10.0.2.5. Remember, that tells it what machine we're trying to attack, because IP addresses are unique identifiers that allow you to differentiate between machines. Then I'm going to set my remote port to, well, we can actually keep it what it was. It was 21. We noticed it was 21 here as well. So that should be good to go. Now, some Metasploit modules support check, which allow you to check whether the exploit's going to work before actually doing it, because once you're doing it, that's the point where you're actually breaking into the computer, and that could be noticed. So check is like, will this work without having to actually do it? So you know right away whether you should keep going or not. Then exploit is to actually exploit, or you can type in run. It's the same thing. Now from here, it looks like we have root privileges. So that is ideally what we're going for. And I can check that by saying ID. And let's make sure we're on the computer we think we're on, which we are indeed. We're on Metasploitable, which was that vulnerable machine that we were trying to attack. So great. So that's generally the pen testing process right there. A lot of the times, if you can't get into a computer through looking at the services that are running on it, let's say you don't have a vulnerable service, if it happens to have a website like this one does on port 80, as you'll notice, you can find, sometimes you can find some web vulnerabilities and get in through there. So I'm going to show that next. I'll show you some web vulnerabilities. So I'm going to navigate to this computer's website just by typing in its IP address, which is 10.0.2.5. You can see I did it before. And you'll notice that we get this nice welcome screen. I'm actually going to be showcasing this part of it, the damn vulnerable web app. That's what DVWA stands for. Now, In theory, you're supposed to look this up and figure out the username and password. From there, you'll find the challenges. But I think that's kind of boring. I think we should brute force our way into this because they made it such an easy login. So why not show you how to do that while we're at it? So a brute force attack basically means you're going to try every single possible combination. So in this case, since we're trying to bypass this login screen, we're going to maybe make our username admin because that's a typical administrator username. And then we're going to try every possible password combination that can possibly get us in. Now, there's a smart way of doing that called a dictionary attack, where instead of going through every possible combination, going A, B, C, D, so on and so forth, and then adding 2, because that could take all years, you would take a list of the most common passwords and try those most common passwords. So that's what I'm going to show you right now. This does, however, take some setup because first we're going to have to actually look at the network packets that are being sent when we're trying to submit our login information. So in order to do that, I'm going to use a program called Burp Suite. And Burp Suite allows me to intercept those packets. Intercept means look at them before they are actually sent out and modify them before they're actually sent out. Shoot, that's the wrong one. I have to. Also, there's a weird thing in Kali Linux where you have to be Kali, the user Kali, and open Burp Suite that way, versus if you open it from here or from the menu, or if you open it as root, it gives you the wrong version of it for some strange reason. But yeah. So while we're doing that, we might as well set up what's called a proxy. The proxy is gonna, I apologize for all this nomenclature that I'm just throwing at you now. But a proxy is what allows us to route the traffic through Burp Suite, which is the name of this program, before it's actually sent out into the internet. So to do that in Firefox, we're gonna go here, we're gonna go to Preferences, then I'm just gonna search proxy. And then I'm gonna manually configure the proxy, set it to this current computer. This IP basically points back to this computer. And the port for that is 8080, as opposed to the normal port 80 that you would connect to web traffic on. And then from there, Burp Suite will forward it or send that information that it caught onto the internet, or over to the internet. So looking at this, I don't know why I opened 2. I'll just close this one. Yes. Intercept is on, meaning everything I type in here, like let's say I type in a random password and I click login. So before it actually gets sent out to the internet, it intercepts it here and I can see exactly what is being sent to the internet. So when you connect to the internet, when you click that button, what it does is it actually sends this. It sends this text with all this information in it. And Burp Suite allows us to see the text itself and modify the text itself at the lowest level. So I think that's kind of neat. You'll notice that the username and password that we entered are right here. I entered ASDF as the password. And so when we're doing our brute force login, we're going to be using that information. Now I'm going to be using a tool called Hydra to do this brute force login. Let's actually use this terminal, sure. And what Hydra allows us to do is try all those different combinations at once or do a brute force attack. So the way I'm going to do that is I'm going to use Hydra. The first thing I need is the username, which we're going to try the username admin. We're actually going to try a password list. Now, Kali comes with a password list called RockU. I don't entirely remember the history behind that, but I know there is some history behind that. There was a giant password leak, and RockU is like the most popular passwords from that password leak. So we're going to try those. And it's stored in the word list directory, and it's called RockU. I should be able to tab complete, yes. Then the remote computer that we're attacking in this case with a brute force attack. One mistake is going to mess this all up, so I have to be very careful here. This is a post request as opposed to get request because we're posting login information or we're sending in login information. A get request would be obtaining information from the server. Here we're sending information to the server. That's why it's post. That's why I had to write HTTP post form instead of HTTP get form. Then from there, we need the exact page, which the page is written right here. So we're going to copy that. Might actually copy the whole thing, which I don't want it to, but we'll see in a second. Yeah, to copy the whole thing. I want just to copy this last part right here. Then from there, we need the information itself that we're actually going to be sending. Sorry, I just saw the question. The proxy, what the proxy does is the proxy allows us to, instead of sending traffic out to the internet, we send it to a different port on our own machine. Now, this Burp Suite service, or this Burp Suite application is running on port 8080, or it's listening on port 8080. So we're essentially sending the information to ourselves, but we're sending it to Burp Suite, which is on port 8080, and from there, it sends it out to the internet on port 80. So that's how the proxy works. The proxy basically tells it, instead of going straight to the internet on port 80, I want you to send the information to Burp Suite on port 8080. And that's on our own machine, not on the internet. Anyway, hopefully that answered your question. Continuing on, then we need the actual information that we're entering. Copy. I don't know if I should do copy URL or copy. There, I should do this copy. That'll work better. Paste. Now the two things we'll have to change is, instead of having admin as our username, we're going to use the flag user, and that's going to replace whatever is right here, or that's going to replace the information that would normally go right here with the actual user, which in this case is admin. So we could have just left admin, doesn't necessarily make a difference, but I like to look at it that way, because we're going to do the same thing for password. We're going to go PASS for password, and that's going to cycle through all the passwords in this word list. Now, the last thing we need to do is we need to know when we found the correct password. So how do we know that? Well, we either have a failure message or a success message. If we know what it's supposed to look like when we log in, we can put in a success message. Otherwise, if we know what it's supposed to look like when we fail login, then we can put in a failure message. So to set up that proxy, to continue your question, sorry, I'm kind of jumping here, but I do want your question to be answered. I went to the settings in Firefox, and I literally set it to go right back to this exact same machine. So it's pointing back to the machine I'm currently using. That's what I'm doing by using this IP. This IP is kind of a reserved IP for accessing this machine. And I'm choosing port 8080 so that I can go to Burp Suite, which is already listening on that port. Yeah, hopefully that answers your question. Going back to this, we're going to have to actually see what a bad login looks like to get a failure message. So what I'm going to do is I'm going to forward these packets, which means send them out to the internet. And now that we sent them out to the internet and got our response, we can see that it says login failed. So we know that every time we fail our login, it's going to say login failed. So what we can do is we can say our failure message is, I'll just use failed. And what this is going to do is it's going to look if anywhere on the page it sees the text failed, then it'll know right away that it failed, and it will keep going to the next, trying the next password. Whereas if it doesn't see this word, then it knows we made it in. So it knows that we got the password. I'm also going to do -V, and that's going to allow us to see more printed out information about what passwords it's actually trying. If you don't do that, it'll just show you what password works, which is fine too in this case. And if I typed it all correctly, which I very hopefully did, you see that it attempted all these logins. It attempted admin, this password, admin, this password, and finally it found that admin and password works. So long story short, guys, do not make your password password. It is a very terrible idea. You are quite welcome. And I'm going to turn off the proxy now so that we can directly access the internet, because we don't need Burp Suite anymore for anything. I know that all that proxy stuff is kind of confusing. So let's try that login, if apparently it works. So password, cool. And now we broke into the damn vulnerable web app. Now I'm not going to show you brute force because that's literally what we just did. Let me make sure the security is low just so that I can demonstrate the most basic attacks and they'll make the most sense. The first kind of attack we can do through a web application is called a command execution attack. This is the simplest of all of them probably. And this basically means if the website allows you to somehow execute commands on it, you can potentially execute commands that you're not supposed to be able to execute. Like the intended use of this is you enter an IP address and it pings that IP address. Pings means it checks if it's on the network. I think I talked about that earlier. Pinging is checking if a computer is on the network. We did a ping scan, or what's known as a ping sweep, which is pinging all the IP addresses on the network to check if there's a computer there. Yeah. So let's just use it the way it's supposed to be used. You can see I was already messing with it there, but let's just use it the way it's supposed to be used. We can ping this computer. If I click submit, you'll notice we got the ping information back. So what this looks like it's doing, yes, actually that is, sorry, I'm kind of looking at the chat here too. That is what a lot of people do. So if you'll notice, if you get your username and password combination incorrect, I know for IIT it's 3 times. They're going to lock you out of your account, and you have to call OTS to get you back into your account. And the reason for that is so they can stop brute force attacks like the ones I was just showing, because now you're required to, now you can't keep trying more combinations. Now you're required to go through an entire process to give yourself access to that login screen again. So yes, definitely, a company should do that. I agree. Now, back to this anyway. So what it's probably doing is it probably has some code that's running ping, and then whatever you enter here. So whatever I enter in this box, it's probably going to put it to the right of the ping, or at least that's my assumption because that's what it looks like it's doing. So if you know anything about the Linux terminal, you know you can string together commands by adding a semicolon and then adding another command, and that means fun fact, 2 ampersands is if this command executed successfully, it would execute the next one, whereas a semicolon is it'll execute the next one regardless. So what we're going to do is we don't even have to enter an IP. We're just going to put that and put a completely different command to the right of it. Now, what am I doing here? I'm creating a netcat connection. Netcat is a service that is available on almost every Linux distribution. I'll answer that question in a second, sorry. However, the good part about that is that you can most likely use it for command execution. Now, what it is used for is it's used for remotely connecting to another computer. So essentially what I'm doing here is I'm sending this code. This is my payload right here. And what it's doing is it's taking bin sh, which is the actual interaction you have with the terminal itself. That's the program that's in charge of that. And it's executing that and sending it over back to my computer. So if you'll notice, once again, my IP address is 10.0.2.4. So I'm having it connect back to my computer, and I chose port 443 because that just tends to work because it's another HTTP port. Most computers don't block it. So on my computer, what I'm going to do is I'm going to create what's called a listener. So I'm going to listen for incoming connections. Once again, here I'm creating a reverse shell. Maybe it'll be helpful if I go back to the diagram of the reverse shell. So in this case, I'm the attacker. What I'm doing is I'm opening up my computer so that it can listen for incoming connections. Now, to do that, I only have to choose the port that I'm opening it up for incoming connections on. So that's what I'm doing here. Also, I have to sudo, which is really annoying, but we're going to do that. Yes, guys, never forget you need root privileges for a lot of things. All right, so now it's listening. So that's what we wanted to do here. Now we have to send some sort of malicious code to our target that's going to connect back to us. And that's exactly what this code does here. It says connect back to us on the same port that we're listening on and execute this, I should say, file that allows us to interact with the other computer. So if I click submit now, you'll notice that the website hangs because it is currently interacting with us over here. Sorry, I have so many of these open. And you'll notice we got a connection here from them to us. And I can check that. I can say, who am I? And you'll notice I'm www.data. That's one of the users on the computer. That's actually the user that's in charge of handling websites. That nobody actually uses that user, but the purpose of that user is to handle website data. And then I can make sure I'm on the correct computer by doing uname-a, and you'll notice that that's Linux Metasploitable. All right, let me answer your questions now. Is there a way to automatically change your VPN every login? Thank you. I'm not entirely sure what you're asking about that. The purpose of a VPN is to connect to the internet, but route your traffic through another computer or through another machine before it actually goes out into the internet. That's what a VPN does. And another use case for it is if you want to connect a bunch of computers, but you don't want them to be necessarily exposed to the internet, but they're very far away, so you can't have a local area network, then you would set up a VPN or a virtual private network, and then you'd all be able to connect to that virtual private network, but that traffic would not actually go out into the greater internet. It would just stay within that network. So I don't see how changing what VPN you're using every login would have any effect on how successful you are in conducting an attack or stopping an attack. Hopefully that makes sense. I could give you a whole lesson on VPNs. They're very interesting. Yeah, Cam, kind of, yeah, my comments applies to what you said too. Okay, so that's a good question. What I'm doing right now is I set this up on this computer. So this is my personal computer. Actually, I mean, it's theoretically the ECE department's, but none of this, I'm not attacking any computers that are out on the internet right now. They're all set up on my computer. You could use the exact same process to attack other computers on the internet, but I'm just using the ones that are locally on my computer that I set up for the purpose of attacking them. So no, I cannot get in trouble for doing this. And that's why I'm doing it this way. If I was attacking some other computer that I found out on the internet, I could use these same exact techniques, but I would get in trouble for it. Whereas here, I'm just using it on machines I set up. So I'm practicing the techniques, but I can't get in trouble for it. Would it trick the company to think they... Oh, actually, yeah, that... Yes and no. That's actually a good point you're making. It might trick the company in that sense, but usually when you do a login, you're trying one username and multiple passwords. So they don't lock you out depending on what computer you're connecting from. They lock you out depending what username you tried. So if you tried the same username 3 times, it's going to lock you out. So that's, yeah, that's why that wouldn't work. But good thinking there. I see where you were going with that. All right, anyway, I'm going to continue. I had way too much prepared, apparently. I could go all day here. So we're going to kind of skip the rest of these for now. But these are more popular attacks like file inclusion, upload, SQL injection. Now I want to show you some of the... So if you try to attack your other laptop on the network, I mean, theoretically, you're not doing anything illegal, so they shouldn't be mad at you. I don't know how closely they're monitoring the traffic, and depending on what kind of attack you're doing, they might not allow it. But yeah, I'm not entirely sure about that. That's why we set it all up on this computer. Actually, I have done a phishing attack from my house on one of the computers here, and nobody got mad at me for it. So phishing attack is what I'm going to show you next. But I'm not necessarily saying you should go ahead and do that. I only did it on my own computer that I owned, but yeah. So next I'll show you kind of, these are the flashy attacks that people, you can set them up really quick and everybody's like, whoa, really? You can do that? It's that easy? So what I'm referring to is social engineering attacks, also known as client-side attacks. I don't know that I want to call them client-side because it is, it's not the same as this client and server that I was talking about earlier. Client-side attacks, also known as social engineering attacks, are where you attack. You don't necessarily target the computer or vulnerabilities on the computer. You target people's own stupidity to run things on their computer and give you information. So the most popular one, which you've probably all heard of, is the phishing attack. Now, actually, earlier this week, one of my friends got an email that was a fake email and asked and said your ID is like whatever, you need to reactivate your ID or something. And then it took him to a login page. And then if you enter your login page, the attacker would get your info. So I thought, hey, that's pretty neat. Why don't I demonstrate that? So I'll demonstrate exactly how that person would have done it. Of course, that person was not authorized to do what they did, and they targeted a lot of people. And I know Illinois Tech student community was talking about it. Is this legit? No, it wasn't legit. It was a phishing attack. But I'll show you how to do it, because why not? So the first step is to clone the IIT login page. I'm actually going to do that. Clone the IIT login page and host it on our attacking computer. So the nice thing is in Kali Linux, there's something called the Social Engineering Toolkit, and it kind of has a set of scripts that does a lot of the dirty work for you. So we're going to be using it. We're going to be conducting a social engineering attack, website attack vector, because we're cloning a website. It's a credential harvester attack. That's what it's called, because ideally, when somebody enters their credentials into the site that they think is legit, but we're actually hosting, those credentials will come to us. That's why it's called a credential harvester attack. Then I'm going to do a site cloner. I'm going to clone a site. And the IP address for the post back in all those words, that basically means where the credential is going to be sent to after the person connects to your computer. So I'm just going to send them back to this computer. I can press enter because the default value is, in fact, my IP address. Now we're going to enter the URL to clone. So if you go to, let's see if I can go to it real quick, login.iit.edu, that's how you get to the login page. So we want to clone this site right here. So I'm going to copy and paste that. I'm actually just going to copy and paste this part. I don't think I need the whole thing. And now it's cloned. And Social Engineering Toolkit automatically set it up so that it started a web server for you and it's already running. So I can actually access it by going to my own IP address. So my own IP address is 10.0.2.4, which I think I showed you multiple times. And you'll notice if I go there, I have an exact duplicate of the IIT login page. So that's step one. And then I can prove to you that I can also access it from another computer that's connected to this one. You can't access it because I'm hosting it using my local IP address, but any of the computers that are here in this local network connected via the NAT network can access it. So I'm just making sure nobody online has access to this because I don't know, I could get in trouble for that. So if I do that, I can also navigate it to it. I should have mentioned I switched to the Windows machine here. So before I was on my attacking Kali machine. Now I switched to the Windows machine. And when I say machine, I mean operating system. I use the words interchangeably. So here I'm on the Windows machine, and I can still see that same login page. And you'll notice that if I type in my information, like J411, and then my password, and click login. Well, first of all, it redirects back to the same page. We're going to change that because it's kind of funky that it just redirects right back to the login page. That's like, wait a second, something's up here. We're going to have it redirect to iit.edu, which is what the person who did that phishing attack actually did. And then if I go back to my attacking machine and look at that same terminal that I created that on, you'll notice I got this bunch of text, but here you can see it did find the username and the password. So I got J411, which is my username, and then haha, you lose because they didn't want to type my actual password. So the next step to make this better is we're going to redirect. We're going to have it automatically, once they enter their login credentials, we're going to have it redirect to, let's say, iit.edu or something that makes sense. So in order to do that, I'm going to stop this for now. And I'm going to edit. There's a specific file I have to edit. I actually have it written down here so I don't forget it. It's in @c set toolkit, which is what we're using, and then set.config. It's a configuration file. So if I search for harvester redirect, and you can look all this stuff up online, that's how I know about this. You'll notice that currently it's off, so it's not going to redirect you anywhere after you enter the login information. I can turn that on, and I can say, I'll redirect to it.edu. All right, we can save that. Also, I'm editing this file using Nano, which for those of you who aren't super familiar with computers, that's how you can edit files from within the terminal. The terminal is this basically text thing where I type out a command, what's known as a command, and then it spits back information at me. So I probably should have mentioned that earlier, but you know, if you're interested in cybersecurity, it's probably likely you know some of that stuff already. So now if we do it, I don't know if I actually have to exit out of this and reload it, so I'll do that just in case. All right, 1, 2, 3. I'm doing the same stuff I did before, exactly the same. I'm not doing anything different. Now you'll notice that if I go on this page and enter my login information, I'm doing this on my attacking computer, but it's the same thing as if I did it on the other computer. It's literally the same thing. I showed you on the other computer that you have access to it. So if I now go J411 and go like, and then log in, you'll notice that now it redirected me to iit.edu. So now it looks more official, like, oh, I actually got to the page I was thinking of. So if you were smart about this, not like the guy who did that phishing attack, but if you were smart about this, and I'm not suggesting you do this, I'm just suggesting if an attacker were to do this, what they would do is they'd think of some resource that you want to access, but maybe you have to log into Gmail in order to access that resource. And then it would redirect you to that resource after you fill out the login information. And of course, it spit back what I entered, which is my username, and then kittens are cute. So the next step, that's part of it. Now, how are you going to actually get your target to visit this link? This really weird link with dots in it. Well, why not send them a spoofed email? So what do I mean by spoofed? Spoofed means you're pretending to be somebody who you are not. So I'll send an email from I'll pretend it's from one of my Google accounts or from one of my Gmail accounts, but it won't actually be from that Gmail account. So Social Engineering Toolkit also has really nice built-in scripts that allow you to do that. I set up my own SMTP relay. What that means is SMTP is Simple Mail Transfer Protocol, I'm pretty sure. And that's on the lowest end, the information that gets sent back and forth between the mail server that handles your emails and you. Or that's the protocol for it. So I already set up a relay, which is going to take the information that I send it, and I'll show you how I send it to that relay, and then it'll send it off for me. So that's one thing you might have to do if you want to do this on your own, but that I'm not necessarily showing you right now. But the fun part is once you do that, let's go back. We want mass mailer attack now. Oh, I also forgot there is a weird thing about Social Engineering Toolkit where they switched from Python 2 to Python 3 because it's written in Python, and that messed up some of the dependencies here. So I actually have to run this. This took me a lot of figuring out why I kept getting errors until I realized that I have to run this using Python 2 explicitly. So normally I can just type in SE Toolkit, but in order to do a mailer attack, I have to type in Python before it so that it knows to use Python 2. Anyway, little side note there. Now we can do our mailer attack, and I'm just gonna do a single email address. I'm gonna send it to my personal email. So I'm sending a spoofed email to my personal email. I'm going to use my own server relay like I talked about earlier. The from address, I can choose whatever I want as long as it's a legitimate email address, because the relay I'm using actually checks if it's legitimate. So I'm going to use one of my own. I'm going to use an old email that I never use for anything. Feel free to spam it because I never look at it. And then the from name, I can choose whatever I want. I'll just say John Doe. Look at me, I have the most generic name. Now, in order to access my relay that I'm going to be using, I actually have login credentials for that relay that I created. So I'm going to use my login credentials for the relay. And then the password. And then the actual address, which in my case, I used SMTP2Go. I know this is a bit of setup, but it's cool once you get it done. And then the port for that is, I believe it's actually 2525. So we'll go with that. I'll mark it as a high priority message. And I'm not going to attach a file, but you can if you want to. I'll make the subject read me now. Woohoo. And the nice thing about this is it lets you send the messages either plain text or HTML. HTML means you can add the tags. If any of you are familiar with programming in HTML or scripting in HTML, you can add tags that give text certain effects. You can create paragraphs or headings and bold and italics, but I'm just going to use plain text because that's all I need. And then I say, hey, look at this link. And then I can send the link. Or I can say, go here to activate your ID card. 10.0. I don't even remember what it was, 2.4, yeah. Right? Yes, correct. And then I'm going to say end to end the message. And now it should have sent the email to my Gmail account. So we're going to check if it's actually there. Sometimes you have to be very careful to enter the information correctly, because if you enter one thing wrong, it's not going to work. So now you'll notice I got an email from John Doe that says, read me now. I'm surprised it didn't go to spam. Wow. All right. And it looks like if I look who it's from johnfordcollege@gmail.com, even though I never actually entered my login information for that email account, ever. I entered my login information for the relay that I created and I set up. You'll also notice that it says via smtpservice.net. That's a nice thing that Gmail has in it to prevent these sorts of attacks from happening. You can always see if it's being routed through a third-party service like what I'm doing right now. And there's kind of no way of getting around this. So unfortunately on your phone, I was looking at this on my phone earlier, this doesn't show up. So you do have to be careful. People can just spoof their email just like that. And you'll notice it says, read me now. And it says, hey, look at this link. And I'm like, oh, okay, I'll go visit this link, I guess. If I go visit the link, it should take me to, I probably entered it wrong. I know it worked earlier. I just entered it wrong, but it should ideally take me to the login page. Or actually, I think, never mind. I think I actually stopped sharing the login page, so that's why it didn't work. But that's fine. If I closed out the login page, I stopped it here so I could do this. But ideally, I would still have that running in the background, and then you can visit the login page like that. But you saw how that works already. Another thing people will do to make this attack more believable is they'll try to replace this link, because this link looks really strange. They'll replace it with a tiny URL link. So they'll take this, paste it into tinyurl.com. They'll go to tinyurl.com, paste this in, get a tiny URL link, and try to send you that. Fun fact, Gmail actually marks that as spam normally. So if you actually, for any reason, wanted to conduct this attack, don't do that because it's going to mark it as spam. Whereas the one I sent wasn't marked as spam. Another thing people do is they might put it on there. If they own a website, they might put it as a page on their own website. So yeah, that's kind of what a phishing attack looks like, as well as email spoofing. So those were some of the client-side attacks or social engineering attacks. Another one is, I just wanted to demonstrate this really quick so I could also show off, this is going to be the last one for the day. Sorry, I know this is running late. So somebody could impersonate. So there's a difference. I want to highlight the difference between sniffing and spoofing. I didn't talk about sniffing yet. So sniffing is when you intercept emails that people send to each other, or when you intercept data that one person sends to another. Whereas spoofing is when you pretend to be somebody else. So sniffing emails would be substantially more difficult because they're encrypted. I actually don't entirely know how that works. Maybe I shouldn't speak to that. But spoofing, you could pretend to be any email you want, really, as long as it exists. So yes, you could pretend to be a security company, or you could pretend to be a CEO of something, and you could pose as that person. So it's actually relatively easy. It's what I just did right here. Except, of course, as you saw, Gmail will let you know that it was routed through a third-party service, but some people actually do that. Some people do that. Like, for example, the head of housing here does that. I received an email from her because I had to meet with her about something, and it was routed through third-party service. And I'm like, wait a second, this is really sketchy. But no, that's just how she sends her emails. So sometimes you can trick people that way. Yeah, it's not, the purpose of that service is not to be used for this. The purpose of a relay is not to be used for this. The purpose of a relay is to be used so it's easier for you to send your emails, but that opens it up for hackers to do this kind of stuff. Yeah. Anyway, what was it going to show? Oh, yes, I was going to show one more thing, which is sometimes, if you're good enough, you can convince somebody to open a file that you want them to open. So here, we're going to use Metasploit, and we're going to use the Meterpreter. Remember, I talked about how the Meterpreter is similar to a shell that you would normally have when you connect to a computer through a terminal, meaning you have commands and they spit stuff back at you. But it's better because it has more options and more commands that you can use. And I'll demonstrate some of those. So I'm going to demonstrate that along with how you can get that to happen by getting somebody to run a malicious file on their computer. So I already created the malicious file because it actually takes some time to create. The command doesn't take a lot of time to type in, so I'll tell you what command I typed in, but I won't actually run it because I already did that. So I used MSF Venom. MSF Venom is a built-in Metasploit, part of the Metasploit framework. It's a tool that allows you to really quickly generate shellcode. Remember, shellcode is code at the lowest level that you can run on your target computer that allows you to get access to the target computer. So here we got, I set the architecture. I set it to 32-bit architecture. It really doesn't matter. Theoretically, I'm going to be targeting this Windows machine just for demonstration purposes. And theoretically, it runs 64-bit architecture, but it doesn't matter. 32 is fine. Then the platform is Windows, of course. Then the actual payload that I used, remember, payload is the malicious code that you send that causes that computer to connect back to you or for you to connect to it, was Windows. This is a built-in payload in the Metasploit framework. There are a lot of these. You can also list these if you do MSF Venom -- list and then payloads, or you can list the different architectures it supports. It supports Mac, it supports Linux, it supports even Android devices or iPhones. You can find various exploits for those. But anyway, we're using Meterpreter, and then once again, reverse TCP. So reverse means it's a reverse shell, as I talked about before, as opposed to a bind shell. So they're connecting back to us. And TCP, as I also talked about before, it's the most accurate protocol you can get, because if we're sending pieces of text like this, we want to be able to send text accurately. Then I have to specify where it's going to connect back to. So the way this actually works is Meterpreter is what's called staged. So if it were to actually send all the code that you wanted to send to your target right away so that you could interact with it the way you wanted to, that would be a heck of a lot of code. So what it does is it actually sends a tiny piece called a stager, I believe. And then that connects back to your attacking machine. Then from there, you send your code as needed to the target computer so that it has the functionality you want it to have. I know that was a lot of words, but basically it doesn't send all the code to the target at one time. It sends enough so that it can connect to you, and then you can send the rest of the code from there as needed. But anyway, so this is my own IP address. So right now I'm creating the file that's going to go on the machine that I want to attack. So it has to know which computer to connect back to. So I'm entering the computer to connect back to, which is the computer that's attacking it. So that's the computer that I'm currently using, Kali Linux. And then for the port, you can choose any port as long as it's not already taken or already in use. I actually use Minecraft port 25565 because somehow that always happens to be the port that nobody's using, unless they're playing Minecraft. Then getting rid of bad characters is pretty important, because if you just generate this as is, then you'll end up creating this raw payload or the raw shellcode itself without any modifications. But certain systems don't like characters that you pass in, depending on how you're passing in these characters to the remote computer. It might not like certain types of them. Like, for example, if you're running an exe file, an exe is an executable file. If you're running that on Windows, it doesn't like null byte characters in that file. It won't read them correctly. So what this is saying the bad character, -B for bad. And then this is the null byte character in hex. So it's hex 00. So we're saying whenever you see that here, whenever you see that in our shellcode, I want you to get rid of it and replace it with something else that works instead. Now, how does it know what works instead? Well, people came up with these things called encoders, and there are some built-in ones. One of the most popular ones is actually this one that I'm going to use. You can also list encoders the same way as you list architecture or payloads. That's MSF-Venom -- list. And then I believe it's encoders. So we're using this encoder, and this encoder is an algorithm that somebody specifically designed for converting these bad characters into ones that are readable by the computer that do not include these. And that makes the code a little bit longer, of course, but that makes it fully readable. Which in this case is not a big difference. And then we do -F, that's the format we want it to be in. We want it to be an executable file. And then we're going to pipe that output. It's not really piping it, it's saving it to a file. That's what the caret does. And then the file name I want to save it to, and I called it test.exe. So I'm not actually going to run this, and I know I spent a really long time talking about that actually, but that's essentially how you would create a piece of malware. So we just created our own malware. Congrats, guys. That's also a backdoor because it gives us access to a remote computer. Now to listen for it, Metasploit has some setup. I think I might just be able to do exploit. It has some setup. What's the word? Shoot, I said it earlier. Whatever. It has a setup way for us to connect back to that malicious file that we just created. So I'm going to use that. I'm going to use the multi-handler, and I'm going to show the options that we have for that. And this is it's called multi because it works across multiple architectures and with multiple types of payloads. So I can choose a different payload if I want to. And it's a handler because it just handles when they connect to us, it handles that connection. I already pre-entered all the information in here because I was testing this earlier. But essentially what I do is I'd say set payload Windows interpreter reverse TCP. I'd set L host. That's the computer that it's connecting back to, which is my computer. When it's R, that's remote. When it's L, that's local. So whenever you see L host, the easy way of thinking about it is whenever you see L host, that's the IP of your machine that they're connecting to. And whenever you see R host, that's the IP of their machine. Sorry, I didn't mean to put an equals. I don't know why I did that. And whenever you see our host, that's the IP of the machine you're attacking. So let's also set the port to 25565. Let's show our options again. And it'll look kind of the same as before because I already did it. So you'll notice we have the payload, we have our L host, we have our L port. And then we can just go ahead and exploit. Now, once again, we talked about this as being a reverse shell. So, or I don't know if we talked about that explicitly, but I think I briefly mentioned it, that the attacker is going to, or the target, the one that we want to attack, is going to connect back to us. So in this case, the person who's running Windows is going to now open the file, which I already downloaded on here, so it's here. And once they try to run this, they see, oh, look, there's an executable file. I can run it. Oh, that's strange. It doesn't seem to do anything. Huh, I thought I clicked it. But lo and behold, if we go back to our attacking machine, we now have a new session opened with our computer, and it's an interpreter session. So we have a lot of options. And if I go help, you can see all the crazy options we have here. So for example, I can take a screenshot, which I will do just for demonstration purposes. And that's a screenshot of what the other person is looking at, the person that we're targeting. And I'll show it to you in a second. I can actually show it to you right now. It's in Home, Kelly, this one. That's the screenshot we just got. And you'll notice it looks just like that other screen. I can also log what keys they press. I can do a bunch of really fun stuff. I can try to steal their, I know there's actually a module for Chrome that if somebody saves their login information like usernames and passwords in Chrome, it can attempt to decrypt those and give you their login information, which is pretty cool in my opinion. Yeah, you really have full control over their computer at this point. Sometimes you won't necessarily have root privileges or administrator privileges. I think in this case I do. So I don't have to worry about that. But there's also a point in the penetration testing process that I didn't really talk about. Probably should have mentioned it. So I'll mention it right now. It's called, where is it? It's called privilege escalation. So let's say you were able to, you exploited and you were able to get into the computer. Well, what do you do? What do you do next? Let's say you don't have access to everything in the computer because you're just a user. You're not an administrator. Well, you have to find other ways, and it's considered part of the post-exploitation section. You have to find other ways of elevating your privileges, meaning getting yourself from just a regular user to an administrator. And a lot of the times the way you do that is you run a lot of, you go back to information gathering, you run a bunch of scripts. Now that you have that computer, some access to it at least, you can run scripts directly on that computer and figure out what services it's running, which ones might be vulnerable, and then you kind of take the same process to escalate your privileges and eventually hopefully become a root or admin user. That's all part of the post-exploitation process. Yeah, actually, on to Cam's point there, be careful because a lot of the things you do can be noted in the log files of the computers that you're breaking into. Like it'll say, you can see the people who are connected to your computer in Linux, or all the connections that are going into your computer. I think it's W. Yeah. So you can see all the shell connections that are connected to my computer right now, which in this case is just me because I'm the only one. But if somebody else connects to your computer, the nice thing about Linux, Windows probably has something like this as well, but I don't know it off the top of my head. You can see who's connected. So you do have to be careful if you break into somebody's computer. You want to stay on that computer for as little amount of time as possible, because the longer you stay, the longer a trace you're going to leave, and the longer they have to spot that you're connected to their computer, unless you're pretending that you're supposed to be connected to their computer for any reason. So ideally, you get in. You get all the information you can possibly get out of the computer. You steal passwords so you can get into other computers, and then you'll leave as fast as possible. Yeah, and along with this, I was starting to say there are log files on every computer. I should know where they are in Linux. I feel so dumb for not. No. Yeah, I think I was right. Yeah, There are log files, and they basically spew out information of who connects to your computer, everything that's happening on your computer. So people can check those log files and see that you've been on there. So a good practice is once you break into a computer, if you have a set of things you can do to erase log files, that's another good thing to do. Yeah, I can keep showing more attacks, but I don't want to keep you guys here all day. I realize I tend to be over-prepared for things. But if you have any more questions, ask in the chat. The next seminar, I'm going to start actually getting into how to do some of these. I know I explained a lot of them right now, but I didn't explain, I didn't go in depth into what every single command I typed out does and what options you have with it. I'd like to showcase, I think I put it on here, if you ever do get into this stuff yourself, and you find yourself forgetting all the commands because there's a ridiculous amount of commands and I don't even remember all of them. I created a Kali Linux cheat sheet that I use all the time because I can't possibly remember all the commands that I use. Let me quickly find that and put a link for that in the chat if you want to take a look at it. It's not going to make any sense to you unless you know what the commands do, but it's a reference there in case you ever forget some of the commands. And I kind of divided it by section too. So yeah, if you have any specific questions. Oh my gosh. For some reason, text is starting to show up weirdly. I don't know why I can't see what's in the chat. There we go. Okay, now I can see it. Will resources for learning how to use these be available somewhere? Yes, the answer is yes. First of all, in the PowerPoint presentation that I shared with you, if you go to the last slide, fill out that interest form, and I will give you all the resources I have, as well as set up an environment for you to practice on if you don't want to set it up yourself. So please do fill out that form if you haven't already. I know Shemek, who's another guy who's on the CyberHawks exec board, he's putting together a place where, thanks, yeah, I didn't get to it in time. There's the cheat sheet. He's putting together a central site where we're going to put all our cybersecurity resources eventually, and you'll be able to access that. And I'll definitely message it in the CyberHawks Slack when we have that, or one of us will. And you can always reach out to me if you want me to message you personally about that. Is it possible to leave the computer completely clean, as in leave with no trace at all? Well, that depends. That depends what you're doing. If you somehow can think of an attack where you get the file on their computer, they run it, you don't necessarily access it, but it takes the information it needs and it somehow sends it to you, and then maybe deletes the log of it sending to you. I mean, in theory, I guess you could be completely clean, but in practice, it's really difficult. But also, another thing to think about is who's going to be sitting there and looking through log files all the time, unless you're specifically hired to do that. Like if you're hired to look through IIT's network and what's going back and forth. But most of the time, nobody's going to be just looking through your log files all the time. So if something slips in there, it's not going to be the biggest deal for you as a hacker. But yeah, it's a good question. Yeah. Okay, so I'll post the interest form link here. I actually have that open, so I got it. I made it a tiny URL link, so it's kind of easy to remember, hopefully. Boop. There you go. That's the interest form, and that's also on the PowerPoint, which I highly recommend if you're going to continue with this stuff. The PowerPoint has everything you need in terms of setup. Setting up your own environment. So I'm putting the link to that again there. The PowerPoint is called Cybersecurity Introduction. The interest form is called Cybersecurity Interest Form. So they're all there in the chat now. Yeah. Yeah, that's true. I mean, I use them because I wanted a shorter URL than all these ridiculously long ones, and I wanted ones that were memorable. So that's the thing with cybersecurity. People invent things with a good use for them, and then somebody takes in somebody's like, hey, I can use this for malicious purposes, and then misuses them. That's kind of how cybersecurity works. Yeah. Fun fact with tiny URL links, this is actually good for if somebody tries to get you with some sort of click on this link attack. If you put a preview before the actual URL, so if you do preview.tinyurl.com, and then you keep the rest of it the same, you can see what website it's actually redirecting you to without visiting that website, which I think is super useful. I don't think you can do that with like Google or goo.gl or whatever they are links, but you can definitely do it with tiny URL. And usually when somebody sends me something I think is sketchy and it's a tiny URL, I will go preview.tinyurl.com and see what it actually goes to. Yeah, literally type this. Here, I'll give you preview.tinyurl.com. So if you don't actually trust my interest form, I don't know why you wouldn't, but you know, I'm a hacker, so what can I say? You can go to that link, and that'll tell you that it redirects to my to the actual form link. That'll tell you what link it redirects to. Fun fact. I know I didn't talk much about how we prevent attacks. That's something I'm probably going to go over at some point. I don't know if I really want to get too in depth now. I want to end this eventually. I'm sorry, guys. I can go on all day about this stuff, but there are some operating systems that are dedicated specifically to collecting log files from computers that might potentially be attacked and looking at those log files and automatically taking actions depending on what shows up. And like Splunk is an example of one of those that you set up the computer, you set up a bunch of forwarders. That means that the computers you're trying to protect, they would forward that information to Splunk. Then the Splunk computer would look at it and say, hey, this looks suspicious. And then this is the action it's going to automatically take, or it'll send it to a person and say, hey, you should look at this because this looks suspicious. So, yeah. Any other questions? Okay. I can stay on 5 or 10 minutes, but you can leave whenever. I'll consider this the end of the presentation and I'll stop recording.